All right, today, midterm review. So, my plan for reviewing is basically to do a lot of example problems and try to talk through, a lot of the relevant things that we've learned and how to use them, and drop in any tips and tricks that I think will be helpful. But first, before we get into things like that, I want to talk a little bit about how I wrote the exam, in the hopes that it will guide your studying a little bit. So actually, before I start that, let me say real quickly, I have, after this, a big list of problems that I'm thinking we could use to review. But if you have specific things that you would want to hear about, specific topics that I might have a problem on, or specific problems even, feel free to drop them in the chat, and maybe we will address some of them. But yeah, I want to start with this exercise, how to write exam problems. And the way you write an exam problem is you take a homework problem or a practice problem from Piazza, and adjust it slightly. So find something about the problem that you can just like switch out for something else and see if you can then solve that problem. So that is how, pretty much how I wrote the exam, was to take inspiration from the homeworks, the practice problems that I have already written. And there will be, occasionally there's going to be a question that does not look like one of the homework or practice problems, but there will be rather fewer of those and many more of these. And part of the reason I'm saying this is to suggest that you do this yourself in the course of your studying. See if you can take homework problems or practice problems and see if you can adjust them to make a new problem. And the idea is that, not to get too philosophical, but if you can solve these problems, then you have learned to sort of obey the rules of mathematics. But if you can write these problems yourselves, then you have learned to command it. So this is somehow a higher level that you will reach if you try writing your own problems. And I want to give some examples. So here's a practice problem from the section on induction, which says, prove that 3 divides n cubed minus n for n greater than equal to 1. And the idea is to prove this by induction. So if you look at this problem, you can ask yourself, what could you change about this problem to make, that would also be true. So for example, you could switch out the 3 for a 5. Remember, this is related to Fermat's little theorem. So if you choose something that is not a prime, well, it's not that you can't ask that question, but the answer may be different. But yeah, so that's how this practice midterm problem came into being. Let's see another example. Show that the cube root of the square root of 3 is irrational. This also was an example we did in lecture to show that the square root of 2 is irrational. So we've seen a couple examples of this. And on the practice midterm, you will see that there is a problem to show that the cube root of 2 is irrational. And the idea is that you should be able to do this in a very similar way to this other problem. So you can switch out the number inside the square root for some other number and see if you can solve it in that situation. You can switch out the square root for a cube root or a fourth root or a fifth root, and see if you can solve it in that situation. And one more example. Here is a problem from the homework. Prove or disprove that if the composition of two functions is surjective, then the second guy in the composition must be surjective. And here is an exam problem, a practice midterm problem. Prove or disprove that if two things are injective, then the composition is injective. So this is an example of, let me talk about this for a minute. Along these lines, suppose you have two functions, f from a to b, and g from b to c. So this is the setup where we consider the composition g follows f, because this codomain has to be the same as this domain, and then we can make the composition g follows f from a to c. And there are many questions you can ask precisely along these lines. Basically, what is the relationship between all these things? So f can be injective or surjective. G can be injective or surjective. And the composition can be injective or surjective. And there are some rules for if you know that, for example, if you know that f is injective, can you conclude that either of these other two things are? Or if you know that both of these are injective, can you conclude that this thing is? And if you know that this thing is, so what are we saying in this homework problem? We're saying, suppose this guy is surjective, can you conclude anything about this? So how could you tweak this even more? Well, you could say something like, can you say that f is surjective? Or can you replace these both with injective? So there are many problems along these lines. And again, in addition to being able to solve these problems, I recommend that you try to explore them on your own, in the sense that try to figure out for yourself what are the patterns and what are these relationships. But okay, so that is my little that's my little exam inspiration. But now let's go on to doing some examples.